how many bagels, it says write an expression to show how he could figure out
How many bagels are we talking about?
well, that's what I'm asking. How many
Yeah.
bagels are we talking about? It's in the problem.
Oh,
A dozen. How many is a dozen? 12. So this right here is important, so go ahead and highlight that. We have a dozen bagels. That's 12. So we are really talking about 12 bagels. And that will equal some cost, is what we're trying to figure out. 12 bagels going to equal some cost. And I put bagels in parentheses just because that would be like the price of the bagel. And I know that I supposedly say that weird, I have an Appalachian accent. So what do we know about his price? Do we know how much his bagels actually cost? Abby?
It says the baker decides to charge 5 cents more per bagel.
5 cents more than what?
Then the unknown price.
Than the rival, right? So we're charging 5 cents more compared to his rival. So today's homework is 8 to 4, which I need to make live still. I think, or it might be in the folder already. Did you say it's not, or it is? It's not there. All right. So, his rival. Do we know how much his rival charges per bagel?
No.
No. So what do we do when we don't know something? Use a variable. So we are going to say 12. Now, switch back to pen. This is not dollars. So this is going to equal some price. So this is 12, like the amount of bagels, times, and this is where price comes in. So our rival's price, let's just say P for price.
so once you add the 5 because it's 5 cents more.
Yeah, now be careful. If we want this in terms of dollars, when we go to add the 5, we're going to add 5 hundredths because we're adding 5 cents. So once I know my rival's price, I add 5 for the single bagel price. Then I multiply it by 12 to get my dozen price. So this would really, if I want to rewrite the expression as an equivalent expression, it would turn into 12p plus, ooh, be careful, if we distribute this, the 12 would come to the p and the 12 would come, ooh, yeah, plus 60 cents. So his dozen price will be 60 cents more than his competitor's dozen price. And at a difference of 60 cents, if these bagels are better, I'm going to pay the extra. Like, that's not much of a difference. So that's why they say the baker boldly decides to charge more. When you decide to charge more, you're saying my product is better. Who went to Phoenix Fair? Did you see Neomon selling bath bombs?
Yeah.
He was the most persuasive salesperson I've ever seen. And what he kept saying, and I was kind of like, I told him like chill out about it, but he kept saying mine are better than theirs. He kept saying mine are more expensive, but they're better than the like. There were other people selling bath bombs, and he kept saying my price is higher because it's better. So you just tell people my price is higher, my product is better.
I was sick.
I'm
It's
sorry,
when
I
you
know.
go to school with them.
Huh?
It's kind of weird to say when you go to school with them.
I well, I gave them to my mom for Christmas, so I'll have to see if she's used them yet. But he said he made them just like Lush or Posh or something. I don't know, some place that actually sells them. He said he like stole the recipe.
Stealer.
When we're solving these equations, one of the most dangerous things, and one of the things that I've seen, I just graded Accelerated 7's Chapter 8 tests. There were still mistakes that come from the distributive property. Because people are trying to work too quickly, you're trying to skip over steps, and you're not thinking. When we see a number right up against parentheses, the first thing I should do is what? We're gonna multiply, but the absolute first thing I do. I'm gonna get there, but what do I do? What do I draw? The arrows. So everybody draw your arrows. A goes to the B, and A goes to the C. A goes to the B, and A goes to the C. Now, what's the difference between these two expressions? One's addition, one's subtraction. So this is going to become A times B plus A times C, whereas this becomes A times B minus A times C. So you got to be careful with that sign. It's got to go with it. So that sign was attached to the C. It's still attached to the C, but now it's attached to the AC. Air conditioning.
Those are actually my first two initials.
Yeah. So when we work to solve these equations, all I want you guys to do right here to start is do the distribution for each of these. That's all I want you to do to start. Just do the distribution. Draw the arrows, do the multiplication, clean it up if you need to. Three-thirds. I'm losing my mind. What I wrote in blue up here might be slightly awkward compared to yours. So give me your eyes back for a second while we debrief these. We're going to do green first. We're going to do the first one. I wrote out everything. A lot of you won't write out all of this because you do the multiplication in your head. But I wrote out negative 8 times x is going to give me negative 8x. And then plus a negative 8 times 0.3 gives me what? What is it? So forget about the decimal for a minute. What would 8 times 3 be? Forget about the decimal and the negative. What would 8 times 3 be? 24. Bring the decimal back in to 0.4. Now bring the negative back. Negative 2.4. And that all equals 3.6. We'll come back to solve that in a second. Over here, notice what I did was actually looking at that subtraction. Sorry, it's slow and I'm being impatient. This, I did not look at as subtraction. I looked at that as belonging with the 4. That's a negative 4, so I took it as a negative 4. But because I took that as a negative, I had to put something between the terms, and we always assume addition. Like the word and is addition. I have 8b and a negative 4 when I look at this as negative, not subtraction. You don't have to solve it like this, but it's how I think it's easiest. Take the sign with the number, assume addition between the values. But now over here, I have addition of a negative. Can I clean up addition of a negative?
Yeah.
What do I make it? Just subtraction. So this now becomes negative 8x minus 2.4 equals 3.6. And over here, 3/4 times 8. Anyone get that? So do 8 times 3, then divide by 4. Joe? Yeah, so we get 6b plus 3/4 times 4 would just be 3, but it's a negative. And again, I need to clean this up, so it becomes 6b minus 3 equals negative 2. Are we okay with how we got here? What questions do we have for how I got to where we are now? All we've done is, all we did was the distribution. We've not solved yet at all. This might be where you might need some Post-its. Because I'm going to capture, because I'm out of space, but then we're going to continue to solve it. Yeah. So the parentheses are not necessary. They're just there as a grouping symbol. So I use a parenthesis so I can say 3/4 times a negative quantity. I don't have to have that, but otherwise this might look like a subtraction. And I want to remind my brain it's not subtraction. It's negative. So then once I realize, okay, so I'm adding a negative, to clean this up, instead of adding a negative, I just subtract. Does that make sense? So we need, might as well clear this, to start solving our negative 8x minus 2.4 equals 3.6. Over here on my left equation, Kylie, what am I going to do first? What do I always get rid of first, or undo first? Undo the addition or subtraction. So when I look at my variable value, the negative 8 is multiplied with it. The minus 2.4, that's addition or subtraction. How do we undo that, Kylie? So if I minus a negative, how do we undo subtraction? Yeah, we actually add 2.4 to both sides. This will give me negative 8x is equal to 6. Then, Casey, how do I get my x by itself? Do what with the 8? So, back yourself up. What's being done to the x? It's being multiplied. So we want to divide, and we always do it on both sides. What do we divide by? What number are we trying to get rid of? The negative 8. So we divide by the negative 8 on both sides, and that will give me that x is equal to, when I reduce, negative 3/4. If you didn't have to use a Post-it there, you either didn't write all the work or you're writing really small. So that's why I've got tons of Post-its. Guys, we have a bucket, literally a bucket full of Post-its. You can honestly take a stack and keep it if you're going to not lose it. But if you lose everything, leave the stacks here. Any questions on this solution at all? We always undo addition and subtraction first, undo multiplication division second.
Why did you add the 2.4 with the 3.6?
Because what it was trying to tell me to do was to subtract it from my value, and to stop subtraction from happening, I have to turn it into 0. So I had negative 2.4, like trying to act on the variable. So to turn that into 0, I added 2.4, and that actually, what we really did was made this addition subtraction 0. Because this now is negative 8x plus or minus 0. There's no change happening to it. Does that make sense? All we're really doing when we do that is stopping the addition or subtraction from happening.
I'm so confused. I'm like, why is there an x when I'm like, oh, what are we trying to find x?
Yeah. So then this was 6b minus 3 equals negative 2. Now the signs here are where some people have some issues. So, Shane, what is the first thing that we want to do here, working towards getting that b isolated? Yeah, we got to get rid of the minus 3, so we add 3. Now, be careful. If I, right now, have a debt of $2, and I make $3, really, where do I stand financially? I've now made a profit of $1. Negative 2 plus 3 takes me to positive 1. And that's still 6b equal to that positive 1. Anthony, what do I do to get my b by itself now? By Yeah, really, we're dividing 6 on both sides. This just kind of disappears. So my answer just becomes b is equal to 1/6. And if you want the decimal, this is the really cool one. That becomes 0.16, and the 6's repeat forever. 1/6 is a cool decimal to fraction to decimal sort of conversion. But there, we would prefer the fraction since the decimal is a repeating value. The fraction is better. Gravity.
Yes, gravity.
Well, you said, why does this keep falling? Gravity. Any questions? Any of this? We are going to skip past this section. That was when we used the Pearson system, the digits thing.
Oh my gosh.
So, I want you guys try to not move very far. Try to get with people close to you. You do not have to solve these. But I want you to think through, what would it take? Like, what would you do to solve them? So, like, for number 1, I'm going to say, I could solve this by doing blah. For number 2, I could solve this by doing blah and then blah. Like, it might take more than one step. It might take 2 or 3 or 4. So what would you do to most efficiently solve these? I'll give you about 2 to 3 minutes to talk to your neighbors about this. Yes, like you don't have to physically solve it, but you need to write what you would do. So like instead of doing multiplication, you would write multiply by blank on both sides. Yeah.
So you guys can talk with each other.
So I want to make sure that we understand what we're doing. So like Joe, if I asked you, what does it take to solve number 1? Or if I asked you, how do we solve it? Like, what would you do to solve it? Now, dividing by a fraction, we technically try to avoid that. What's division by a fraction turn into? Yeah, so we would multiply by 5/4 on both sides. Let's just say OBS for on both sides. We'll abbreviate because everything has to be on both sides. So you can write OBS if you want for on both sides. And I'm going to fix that 5. So that's all we're writing out is what would you do to solve it. So keep talking with your neighbors if you need more time.
Oh yeah.
Alright, we got a few groups working well, but I feel like we should probably just talk together. Maylee, if you look at number 2, and there's options here, what would you do first? So you would distribute first? So, this is one option. There's multiple. If this is not what you had, don't freak out. So we would distribute -5. So that would have multiplied, and if you care, like we can think through this, that would give me -15x plus 5 actually, on the left-hand side. That's what that would become after the distribution. And that would be equal to 40.
Was it positive 5?
-5 times -1.
Oh.
Yeah, remember the sign in front of the term goes with it.
I just didn't know.
So then, Jack, what would we do following that? So if this would be my equation now, what would be the next step? So we're actually at step 1. If you're looking at like the front of that page or whatever, we're undoing. What do I need to undo here? The multiplication or the addition? Yeah, we got to undo the addition. So to undo addition, what do you do? So my second step would be subtract, and we can abbreviate that. Subtract by 5 on both sides. And then there's actually a third step here. Again, this is where you might need to post it. After I would subtract by 5, this would become negative 15x equals 35. You don't have to write the equation out just to help us think. The last thing we would do, Jaheim, if this was now my equation, how do I get the x by itself? By? You got this. Yeah, so if we want to say this correctly, we're actually dividing by the negative 15. So I get what you were saying. You're saying divide 35 by negative 15. But when I ask you, be careful, because when we write out the step, what we're going to say is divide by the negative 15 on both sides. And that would end our problem. If we actually solved that, that'd be negative 2 1/3, if you care. Now the last one is actually easier. I'm going to capture to get rid of,
Does that say on both sides?
yeah, OBS on both sides.
I kind of abbreviated that.
Darn it, calibration. Get fixed. So, on number 3, Mr. Surface, what would you do first for equation 3 in that solution process?
You would multiply. I know. So you would add 19 to both sides.
Yeah, we would add 19 to both sides. So add 19 OBS.
And you have 36. So then you divide 36 by 3 over 5.
Now remember, division by a fraction, what do we actually do so we can do the math?
Multiply.
By its
Cycle.
reciprocal, so we will multiply by
5 over
5/3 on both sides. And then we'd be done. So we have an example of a 1-stepper, a 2-stepper, and a 3-stepper, where we have to do a distributive. Now, the reason that this was a 3-step problem, that middle one, this is what screws us up and makes it be 3 steps. The fact that it already has a coefficient. There's no way to solve that in less than 3 steps. Unless you skip steps, and then you probably get a wrong answer. Any questions? All right, let's go on a trip.
Yay!
Sorry, not actually. So a family of 6 is buying airline tickets, and travel insurance costs $19 per ticket. I want you guys to go ahead and highlight whatever's important in this problem. Families charge a total of $1,116. How much does one airline ticket cost if each airline ticket is the same price? Highlight what's important. In the no box, we're going to write a verbal equation first. So be careful. Don't work too far ahead. In the no box, we're going to write a verbal equation first. Only if you want to be rushing around. Ha!
Mr. Hudson.
You've heard the Siri thing about fire engines, right?
Yeah.
No.
Sometime later, ask Siri why fire engines are red. Not now.
Oh.
And I don't have an iPhone anymore, so I can't do it. But, so, what am I gonna spend? What do we have to, like, pay for? Michaela, what, like, so we're gonna travel, what are we gonna pay for? 6 tickets. So, we know we're gonna buy 6 tickets. And what else do I have to pay for? Who said it? Yeah, what was it, Anthony?
Insurance.
Yeah, the insurance. Now, when you highlighted things, hopefully you didn't just highlight the $19, because it's $19 per ticket. So if it's 6 tickets and insurance, how many times do we have to pay the insurance? So here's what we really want to do. Instead of splitting these, let's just do 6 times the ticket plus the insurance. Because if I have to pay for 6 tickets and 6 insurances, I could just add the ticket and the insurance and pay that 6 times. Does that make sense? How we can kind of combine tickets and insurance. Technically, there would be a parentheses here and a parentheses here. And what's that going to be equal to? Yeah, we do. We know our total, $1,116. So that, and we'll fill that in here in a second, but that will be equal to our total cost. So now fill in what we know. Do we know the cost of a ticket? No. Lame. Crap. Okay. So we use a variable. I'm going to go ahead and just, yeah, let's use P because T is just kind of rough to work with. So P is going to be the price of our ticket. Do I know how much the insurance costs? $19. So fill in 19 for that. He goes $1,116. I'm going to give you guys a minute and 10 seconds to solve this out. Price of the ticket. Go for it. Well, because I know where I want the second hand to stop. Just so I have a reference. You can work with each other if you'd like. Huh? Yeah, you can just kind of keep. So in the need, we identify we need the ticket price. We have everything but the ticket price. So then in the plan, like we just execute like what we're gonna do. You know the answer. That's a good question.
So subtract on both sides.
Ooh. This 6 on the outside either needs to distribute first before you can subtract, or you have to get rid of that 6. You can't subtract while that 19 is stuck inside the parentheses. So actually, thank you for that question. Hey, Justin just pointed out something really good. This plus 19 cannot be the first thing you deal with because it is trapped inside of the parentheses. So you cannot subtract first. Although your process tells you undo addition subtraction first, that's not 19. That's 19 that will be acted on by the 6.
That's one ticket.
Yeah, well, that's the insurance for one ticket, right? So we can't do that first. We have options for what we could do first, though. So I could distribute, and I would need another arrow, and I could do that. Or, Abby, what else could I do? If I don't want to distribute. Because technically in this process, distribution will add a step.
Also,
And I'm lazy, I don't want to do anything I don't have to.
also what you could do is you could multiply 6 to the 19.
I mean, we would, but that would be our distribution. That would work. I'm not telling you that won't work, but it's not the easiest way.
You do
Let's give Lily a chance. Lily?
Would you do minus 19?
You can't start there. Because this is not 19. This 19 is going to be multiplied by 6. It's not like, it's 19 for now, but it's not 19 permanently. Andrew?
If you divide 1,116 by 6.
We want to either distribute that or get rid of it. And if you want to get rid of it, I'm going to drag that highlighter up. So we'd either have to do the distribution, which we can, or get rid of the 6 by dividing by 6 and dividing by 6. When I divide by 6, what I'm going to end up looking at is the price of the ticket plus that one ticket insurance equals what one ticket and its insurance cost. That's like the per person cost. So what is this division? It's a little under 200. Yeah. 186. So each person cost $186, but that's not the price of the ticket. Now, Abby,
Yeah. You multiply by 6?
but now the 6 is gone. We don't have 6 anymore.
So,
Here,
now don't you... No.
look at what's being done to the
Divide
P.
it by
What's being done to the P?
It's being added.
It's being added.
So, once you do 19 plus 186,
Casey? This is addition. To stop it from happening, we have to subtract. So that tells me this is a cheap ticket. That tells me the price of one of these tickets is, what did you say? 167? Sounds right to me. That's super cheap.
That's
For an airplane ticket, that's really cheap.
It's usually airline.
Did we talk about Airbus yet? So Airbus was this flight company that their goal was to have the cheapest tickets possible. So this only works if your plane is pretty much full. So any seat that wasn't full, that's money lost, right? So it worked for a while until the flights that they had, the times that they offered, like their flights weren't filling up, but they didn't increase their ticket prices because they figured like, our model is let's have the cheapest tickets possible. They went bankrupt. Didn't work for a long term because you can't have a business model like that if you don't cover all of your expenses. They didn't have enough people on their planes, so it's great. Your tickets are cheap. People want your cheap tickets, but there's not enough people to pay for all of your expenses. They went out of business. Yeah. I mean, any airline can have whatever plane they want. You just buy the plane. So, I mean, they probably did for the long flights. Like OSU took a double-decker plane out to the bowl game, which was really, really disappointing. So we'll just move on.
So, to me, I would not ride that plane because if it's cheap, like...
That doesn't really matter. Plane safety doesn't relate to...
Well,
And planes are actually really safe. Like, planes crashing is so rare. It's one of the safest ways to travel. If you look at it mathematically.
If you're driving, it's worse because like there's other
Yeah.
cars.
Mathematically, flying is safer than driving. Yeah.
You're not gonna get
Like, and
traffic.
ask this. What do you think? What's safer, driving or flying?
We just talked about it yesterday.
Oh, flying.
Yeah, why?
Well, there's not as room around you.
Yeah.
Planes are safe.
And I argue air traffic controllers make it safe too. People are watching every plane in the sky. No one's watching all the cars telling you what to do. So we were just talking about cheap
Every
flight
single
tickets.
person driving a plane is qualified,
Yeah,
highly qualified to drive a
they know what they're doing.
plane, not a car.
A buddy of mine from youth choir that I used to sing in, he posted a picture the other day. He took his first flight on an airliner that had people on it,
Yeah.
and I believe it was his father or his grandfather was his co-pilot. For they made it like a thing. Yeah, I thought it was pretty cool too. Like there's not a lot of pilots these days. All right, last problem we'll do today. We mailed 20 identical invitations. Has anyone ever actually mailed like a package? Like not just a letter, but like a package. How does that work? Anthony, you know how to explain this? Like, did you go to the post office? How does it work to mail something? Yeah, so they have to weigh what you're mailing, and the price will change if it goes above a certain point. So, a postcard has no envelope, no wasted mass, piece of paper, that's it, 23 cents. I might be wrong, but that's what it used to be, 23 cents. A normal card, like you're sending a card and an envelope, happy birthday grandma, 44 cents. Anything more than a standard envelope and a card, you start to have to pay extra. So, in this situation,
Well, but then you
mailing each invitation costs 44 cents for the first ounce. But we have fancy schmancy invitations, and they're heavy. So then, it's 17 cents for each additional ounce. Ooh. I have infinitely many colors. I didn't even show you guys this. I can change my highlighter to be whatever color I want it to be.
You went from 2 colors to black. Wait, many colors as you want?
Yeah, it's like the color spectrum wheel. So I could do like weird line colors. Okay, so we need to set this up as an expression, knowing that our total cost was $15.60. Justin?
What happened to mailboxes?
You can still drop mail in the mailbox, but you have to have your postage already. So like it's funny that we're talking about this. I last night walked a card out to my mailbox, stuck it in the mailbox, and flipped up the flag. And the post carrier, because they're not all men, so the post carrier will pick that up today when he comes and drops my mail. Or, if it already had the stamp on it and everything, I can take it to a post box and drop it in there, and it'll get picked up today. Like, they pick up post boxes every day. Your house, it's like once a day if it's a business day sort of thing. So, yeah, but mail's really efficient. Like, our U.S. postal system works really well.
But then you also need to like verify.
I can't text you a physical object. We're not in Willy Wonka land yet.
But then you also have to like verify.
We need to set up a verbal first. We have 20 invites, so 20 invites, and they equal the total cost of $15.60. Now, what is it that I have to pay for each invitation? Not here today. Julia, what do you think? What do I have to pay for each invitation? I know I start by paying.
You divide the.
You're getting ahead of me. You're gonna be right. Like that's actually gonna be right here in a minute, but you're ahead of me. So when we look at what the invitation costs, forget about the 20. What would we pay? Abby, put your hand up. What would we pay for one invitation? So mailing each invitation costs.
Oh, you do the 44 cents.
So 44 cents first,
And then plus the 17.
plus 17 cents. Now, do I know how many additional ounces we have? No. So that's going to need some variable. I'm going to use Z, because ounce, the abbreviation is actually OZ. The abbreviation for ounces is actually OZ. And that will equal the 1560. So now I'm coming back to you because you already tried to tell me what to do. So the easiest way to start solving this now is to do what, Julia?
Divide the 1560 by.
What number are we trying to stop from multiplying? What would multiply into these values? What number is trying to multiply right now?
20.
The 20. This is what we want to stop. So to stop that from multiplying in, we can divide by the 20 and divide by the 20. What that's going to tell me is one invitation costs whatever I get on this side. So we get our 44 cents plus 17 cents for each additional ounce. So 1560 divided by 20. What do we get from that? Yep.
70.78 hundredths.
0.78.
Yeah.
So what that tells me is each invite that I sent, I actually paid 78 cents for the postage. Postage is not cheap. Like my wife just sent out a bunch of baby shower. We're not pregnant. Our friend is pregnant. My wife just sent out a bunch of baby shower invitations. She sent like a stack. I'm like, we paid for all that postage? She's like, yeah. It's like 50 cents every time you send anything. So if we take away the original ounce, that 44 cents, we then get, and sorry, I'm going to write over top of this, but if I was you, I'd use a Post-it. We get 17 cents times the Z equals, sorry, it needs to be 0 point because this is cents. And when we do the division, our extra weight would be 3 ounces. So what that tells me is each invite weighs what? If it's 2 extra ounces, what's its total weight? Yeah.
68.
What was the 44 cents for?
Oh, each ounce.
The first ounce, then the 17 was for the additional ounces. So if I had my first ounce plus 2 more,
3.
each invite actually weighs 3 ounces. And that's kind of heavy because 4 ounces is a quarter pound. So those are some fancy invites. All right, Oslo, go. Sorry, yeah. You can pack up. I'm gonna help you. So, Izzy asked how to get from 2 to 3 real quick while you're packing up. This 44 cents was an ounce. So when we look at this, this was 1 ounce initially, and then these are additional ounces. So we already had 1 ounce, and then we got 2 extra ounces, makes 3 ounces total.
I'm getting